Hello, Form 2 students. In this video, we will go through 10.5, rational numbers and irrational numbers. So please take out your class workbook and write down the learning target today. Number 1, distinguish rational numbers and irrational numbers. Number 2, represent the irrational numbers on the number line. Okay, what's mean by a rational numbers? It is defined by the number that can write in the ratio of two integers. This is called rational number. A over B. And A must be an integer, B must be a non-negative integer. Okay? So that if a number we can express in fraction, then we can call it as a rational number. So for all integers, for example, 2, the denominator is 1. So 2 can write down into 2 over 1. So all the integers can be write in the fraction form of denominator 1. So all the integers are rational number. And of course, fraction 2 over 3 is it is the rational number. Okay, and for terminating decimals, it means it have limited number of digits after the decimal point. So 0.6 is a rational number. You can write in 6 over 10. That is 3 over 5. So we can write it in fraction form. So this is a rational number. And 1.75, it can be write in 7 over 4. So all the terminating decimals with limited number of digits after the decimal point is rational number. And for recurring decimals, that means it has repeated digits or a sequence of digits infinitively. For example, one you should be very familiar is 1 over 3. And when you use your calculator to press 1 over 3, it will equal to 0.33333, and it repeats infinitively. Okay, so the 3 is repeating. So this is so-called recurring decimals. Okay, so 0.18 recurring decimals equals to 2 over 3. So you could double check using your calculator. So for all recurring decimals, it is a rational number. So here we have integers, fractions, terminating decimals, and recurring decimals. They are all rational numbers. Okay? Okay, let's have some questions. Example. Okay, so write down the rational numbers in form of m over m, in form of fraction. So if we can write down in form of fraction, then they are rational numbers, okay? 42, which is an integer, so we can write down in 42 over 1, okay? And part B, it is an improper fraction, 3 and 3 over 7. So it become 21 plus 3 is 24 over 7. Okay, so it is also a rational number. For part C, negative 0.8 will equal to negative 8 over 10. And don't forget to simplify. It is equals to negative 4 over 5. In part D, 1.44 equals to 144 over 100. So simplify, okay? 36 divided by 25. So the fraction, the integer, the decimals, they are all rational numbers. Okay, so what is the form of irrational numbers. So third form, square root 2, square root 3, square root 5, third form is irrational numbers because we cannot write in the form of m over n. We cannot write in the form of fraction. So this is irrational numbers for third form. But of course, if square root 4, is it a irrational number? No, because square root 4 can be simplified to, okay, 4 equals to 2 square, and square and square root cancel each other, so it is equals to equals to 2. So that square root 4 is not an irrational number, okay? Okay, so all the third form are irrational number, and the pi is also an irrational numbers. Okay. So, if the non-terminating and non-recurring decimals, then they are the irrational number. Now, you know what is irrational and rational number. So can you tell which number of the following are irrational or rational? Number A, it is an integer, -9. So it is a rational number. Okay? Part B, third form, square root 10. So third form is irrational. And 5 times pi. Pi is a irrational number because it is a non-terminating decimals. Okay? And then 0.123, 3, and the 3 is repeating, is recurring decimal, so it is a rational. It is a rational number. Okay. Okay. So for rational numbers, we can represent the position on the number line exactly, right? For example, -4.4, you can locate on the number line. 5/3, 2.5, you can locate on number line. But how about irrational number? Can you locate in the number line? So use your calculator. You can find the value of -6 so that you can locate the irrational number on the number line. But for some, for example, for some irrational number, we can locate the exact position by using the Pythagoras theorem. So now we have a right angle triangle. We draw a right angle triangle here, and then we have two adjacent sides is 1, okay? So for the hypotenuse, we can find by Pythagoras theorem that 1 square plus 1 square, okay, and square root. So 1 square equals to 1, 1 times 1, okay? So equal to square root 2. So this one, we can find the value of square root 2. We can find the length like this, okay? And then we can use a compass to draw like a circle using the radius of square root 2. Then you can mark on the number line the exact position of square root 2. Okay, and then we can go on to find the value of square root 3 using the value of square root 2, and then 1, so that here this line is square root 3. Okay, and then again we can locate the value, the position of square root 3, and then once again we can use square root 3 and 1 to construct the hypotenuse square root 4. Okay, and so on.